Thank you. I won't immediately go with the awards. I'll start with a little bit of background and just general observations first. Then what I'll do, I'll present the awards for the teams and then give the score for the 9 different algorithms that were submitted. I don't do that at the front, so that there's a little bit of surprise for who wins, right? And then I suggest that after every announcement of the team, we give a clap, and then at the end of the whole thing, we come together and make some pictures. Yeah. All right, there we go. In the end, only 7 teams registered and only 4 teams submitted. So that was, from the organizers' perspective, a little bit disappointment. We hope to get more, but I also know this was our fault because we were too late, right? So the announcement was probably too short from when we actually were going to start. So I know now that there are lots of people in the room who are eager to participate in our next challenge, and you have a year's notice roughly, yes? So, okay, so together those 4 teams submitted 9 algorithms, so there was a maximum of 3 that they could do. Those are the numbers that were submitted. The outcomes of the challenge, because we set out with some lofty aims, you know, and then afterwards you probably should evaluate what did you get out of all of it. And obviously there are these sample implementations that are open source. All the 3 top scoring teams have made their implementation open source. You can go and get it. It's probably not very well documented. Some of them might be, but they are there, right? And hopefully papers will come. So that's great because, you know, if you want to start, this is probably a good place to start off from. While organizing and doing the challenge, we also found some problems in our own software. So we improved our own software to be able to run the challenge. We had to make lots of scripts to, you know, you get data in from somewhere and then you need to massage it such that it can actually be run. But you want to make sure that the data is what it is because people send you stuff and it has a randoms estimate which is negative or whatever that it is, right? So we made a bunch of scripts to do validation and make some plots and whatever. And those could be useful for you as well. Obviously, there are the Docker images that you can just get with all the software on there. There is a curated phantom data collection. This will end up, hopefully, we're asking people to put their data, the raw data originally on Zenodo, but in the meantime, you can get the curated sinograms and so on already from our website. And we also have the framework, which I hope will be useful for other people who want to run challenges. Obviously, they will need to make a lot of changes, but the overall framework, hopefully, will be good. So those are sort of, I think, outcomes. There were some challenges in organizing a challenge. We discovered a few bugs along the way, which I've always said that there's only one bit of software on the planet that has no bugs, and that's Stir, but it turned out not to be true. So the reference algorithm that we chose, which is a variation of these things, but without stochastics and all of that, in the standard published thing, turned out to be very slow, right? So some of these things, to get to decent convergence, we had to run for a day or 2 days. And then you say, yeah, you look at the convergence curves and say, I'm pretty there. And then you run one of the participants' algorithms and says, whoa, it's a lot faster and it's already much higher than our own reference algorithm. We have to run our reference algorithm for even longer. So that was a problem. And we had that in some of our previous papers as well. But now we have better reference algorithms. It was hard to get enough data, and adapting converters, sorry, it says converters to be able to cope with that. And some of that will become open source as well. It was hard to have computational resources to cope with all of this. So luckily there were no more participants. We did burn 2 GPUs. So yeah, commercial models could come in handy for this kind of thing. And even our cloud system went down right at the end for maintenance. So we were stuck to running everything on one machine. And not only computational resources, but human resources were a problem as well. Some of us didn't sleep a lot over the last 2 months. Okay, so here you've already gathered from everything that you've seen. The challenge for the participants was that this data was not, always the same, right? And so these are just all the algorithms that were submitted on all of the phantoms for one of these regions. And you see wildly different performance, yes? And that was hard. And you see stuff that goes up and then down and things like that. So step sizes and all of that was not obvious to choose. So this was an RMSE over the whole phantom. And this is the absolute error of the ROI mean on one of the spheres of the NEMA phantom. We had a few of those in the data set, as I already said. The challenge here, the metric that we said, you want to go down to 0.05, right, which is really low. It's much lower than you would need clinically. But we thought when we set out all of this stuff, it should be easy to get there in an hour. Obviously, it wasn't. One thing that I wanted to say on this plot is, so we had our metrics, and so this one was we segmented roughly the whole object, and then computed RMSE in there because we said, who cares about the background? And we therefore computed all our metrics there. It turns out that the winning algorithm did very well on all of those metrics, but it did very bad in the background. But it was not measured by our metrics. So were they lucky? Sorry. It was only for one phantom that it diverged. Right, so this is, again, just one algorithm. This is actually not one of the winning algorithms. It did very well on some of the phantoms that some of the other algorithms struggled with. But then for some of the easier phantoms, they had the wrong parameterization. This is the 9 submitted algorithms for one of the more difficult data. This was a Vision 600 data set of zirconium-filled NEMA, pretty noisy, and so maybe a little bit out of the training data set as well. And some were there within 5 minutes or so. Others really had to get to the very end or didn't get there at all. Okay, so I think before we get to the announcement, I do want to acknowledge a number of people. So we did get data from a number of different sites, so many thanks to those. And again, this data is available. We did funding from our network, and so that means UKRI. It's quite good from UKRI to realize the power of software and to put money in grants towards software infrastructure. So many thanks to them. Many thanks to all the participants, but also many thanks to all the people who came before them, right? So that this would not have been possible without a huge amount of open source software. Everything is run on open source software. So that includes SIR and Surf and Stir and Parallel Project and SIL and whatever, but it's Python and SciPy, Matplotlib, Docker, Conda, Linux, everything really, yes? And otherwise, you can't run any of this. Okay, so, right, so I'll go from back to front. However, we didn't expect this. This was only this morning because we have been running repeated realizations, as you know. So we ended up with a tied second place. So the score is per algorithm, but if one team had multiple algorithms, that, you know, we didn't give them 3 prizes, obviously. So Sam, congratulations. And the tied place is for Imraj and Alex. Which obviously means that the winner is for Matthias, Jelko, and Georg. So this is just a final score here on the different algorithms. So these are the ranks. So it turns out, you know, the computation time and so on is so different for the different algorithms because of data sizes, but also for conversion rates. Making averages doesn't make any sense, so we stick to rankings here. And you see that there are some variations in the algorithm that they submitted, but the variations are not really all that important, which is kind of interesting. And then you see these, at the moment we've run this for three different realizations. And the variations in the rankings were actually larger than we anticipated. Not necessarily so much in the actual computation time, but in the rankings, things could flip around. And so the error bar between the second and the third team means that's statistically insignificant. So therefore, so well done. Yeah, so there are some links here. Again, these will be on presentation on our website and all of that, but you can grab the data, you can look at the leaderboard, there is more information there. So by that, let's thank our participants again, and let's make some pictures.